Hi, this is Mr. Royks, and I'm going to take you through a problem dealing with specific heat. So, first of all, let's read the problem, and it asks about the specific heat of a metal. If we have 3.5 gram sample, and its temperature is increased by 15.5 degrees Celsius when it absorbs 25 joules. So, if you remember from class, the formula for this is going to be Q is equal to mc delta T. And so what I would suggest we do is write down the variables that we know. As we mentioned in class, Q, when we're looking for what in the problem represents Q, Q is going to be our energy, and typically it's in joules. So we have Q is equal to 25 joules. All right. Then we have, let's see, what else? Other piece of information, we have mass, and mass is equal to 3.5 grams. It's a decimal place. And then lastly, we have, in this case, it's, delta T, we usually solve for T final minus T initial, but we're told that this is increasing by 15.5 degrees Celsius. So we know that delta T is just 15.5. All right. And now, since we're solving for specific heat, and specific heat is C, okay, I'm going to algebraically solve, and we'll divide both sides by m delta T, and we're going to rewrite our expression that C is equal to Q, that's a Q, sorry, divided by m delta T. So now we plug our values in. Our Q value we mentioned is 25 joules. And our mass is 3.5 grams. Oops, no, I want a decimal place there. Stop it. Sorry. There's a decimal place there. There it is. And then lastly, we have a temperature change of 15.5 degrees Celsius. And we solve. And the value I'm getting when I solve is 0.46 joules, and we go to bring the label over, and the label, nothing cancels, so it's joules per gram degrees Celsius. And that's how you solve that particular type of problem where it's asking for a specific heat. Alright, so now let's look at a different problem. And this problem is now asking us the temperature change of a 0.5 gram piece of metal with a specific heat of 0.75 joules per gram degree Celsius if it absorbs 225 joules. Okay, so again, the formula we're going to be using is we're going to be using Q is equal to mc delta T. And so we're going to, again, write down our values, what our knowns are. We know that Q is equal to 225 joules. I think I ran off the page there. Then we have M, and our mass is 0.5 grams. And then the other piece of information we have now this time is we know what the specific heat is. It is 0.75, and that label is joules per gram degree Celsius. Alright, so now we're going to be solving, in this case, for delta T. So algebraically, right, we're going to have delta T is equal to Q divided by mc. And so now we just plug the values in. Q is 225 joules. Our M value is 0.5 grams. And then lastly, our temperature is, we're solving for temperature. Our C value, specific heat, is 0.75 joules per gram degree Celsius. Now, as I mentioned in class, when we're doing problems like this, whether we use Celsius or Kelvin, that really doesn't matter to us because we're talking about temperature changes, and the scale for both Celsius and Kelvin, 1 degree Celsius is equivalent to 1 Kelvin. So it doesn't matter whether we use Celsius or Kelvin. And so I'm just doing my last bit of calculations here, and the value I'm getting is 600 degrees Celsius is the temperature change for this particular problem. So hopefully this helped you out a little bit more in terms of working through these problems. Again, I strongly recommend, first of all, using this formula, Q is equal to MC delta T, and then, again, writing down the variables as you read through the problem so that you're just plugging them into the equations and solving. And hopefully that helped you out. All right, we'll see you in class.